Good evening to all. Today I am going to start and discuss with Mathematics 2 paper. In that the first chapter is differential equations. So all of you please write, after putting the heading differential equation, the contents or subtopics in the differential equations. Okay. Chapter 1 is differential equation. Okay. So in short, it is given in the form d dot e, that is full form is differential equation. It is of two types: ordinary differential equations and partial differential equations. That is an equation, that is a differential equation containing the derivatives with respect to one independent variable is called ordinary differential equation. Similarly, a differential equation involving the derivatives with respect to more than one independent variable is called partial differential equation. But in GATE, 95% problems given in this ODE chapter only 5% on PDE chapter. Okay. So in that the first basic definition is order and degree of a DE. Okay. See, order of a DE, differential equation. It is defined as the order of the highest derivative involving in the differential equation. DE stands for differential equation. Second one is degree of a DE. It is defined as highest power in bracket degree of the order of the DE, comma, provided the differential equation is free from radicals and fractions as far as the derivatives are concerned. So before that, here write the contents, topics. First order differential equation, both linear and non-linear, comma, initial and boundary value problems, comma, higher order linear differential equation with constant coefficients, comma, Cauchy Euler type equations method of variation of parameters. So these are the contents in ODE 95% problems. Okay, first write the topics and then this is order, degree, basic definitions of differential equation, which are same for both ODE as well as partial differential equation. Now, highest derivative, for example, d square y by dx square, that is the second order derivative. If it is the second order derivative highest, then order of the differential equation is 2. Like that you find highest derivative in a given equation, that order is called the order of the given differential equation. Once we know the order of the differential equation, then the highest power. So first of all, let me say the power, that is the degree of the highest derivative, that is also called the degree of the order of the differential equation, provided the differential equation is free of radicals and fractions. That is, whenever a denominator containing 1 plus dy by dx, you have to remove. Whenever square root of 1 plus dy by dx is there, that square root is called radical, you have to remove. That means finally you bring your differential equation into polynomial form as far as the derivative is concerned. What is the meaning of derivatives concerned? Y dash, y double dash, y triple dash, that is first derivative, second derivative, third derivative. In these terms, the differential equation should be in polynomial form. That is called free of radicals and fractions. Okay. So sometimes definition saying that highest power. For example, in a differential equation, a highest derivative is repeated 2 times like that. Okay. In such cases, you see the highest power. So one example I am going to do. This is given 2010 2 marks. The order and degree of the differential equation d cube y by dx cube plus 4 times square root of dy by dx whole cube plus y square is equal to 0 are respectively solution. D cube y by dx cube plus 4 times square root of dy by dx whole cube plus y square is equal to 0. Here square root containing the one of the derivatives, first derivative. So you have to remove that radical square root. and then you bring the problem differential equation into polynomial with respect to the derivatives. That means we send this term into the right side and then squaring. Okay, so squaring, comma, we get, I am not squaring directly this LHS. First of all, I am sending the second term into the right side and then squaring. This becomes whole square and minus 4 times square root of dy by dx whole cube plus y square whole square. So this simplifies to 16 times dy by dx whole cube plus y square. This is d cube y by dx cube whole square. So now as far as the derivatives, each power is the natural number, that is called polynomial form. Is the differential equation free from radicals and fractions or fractional powers. Therefore order is equal to, what is the highest derivative? Third derivative is equal to 3, and the degree, so it is only one time only it is present in the given equation. So the power of this third order derivative is 2, degree is equal to 2. This is the answer. Now I am giving the definition for initial boundary value problems, linear non-linear equation definition. Then I will start one by one method for solving first order equations methods and higher order linear equation methods procedures. For order, it has no restriction to bring this problem into that form, this form, like that. But for finding degree, you should bring your differential equation into polynomial form as far as the derivatives are concerned. Next. Linear and non-linear equation. Before going to start the procedure, one by one procedure to solve first order equations, let us know the one more, 2 to 3 basic definitions. EQ dot means equation. A differential equation is said to be linear if the dependent variable and its derivatives occur in the first degree only. But are not multiplied together. Otherwise, the differential equation is called non-linear. Now, we have two types of variables. One is dependent variable, other is independent variable. For example, if you consider a derivative like this, dy by dx. Here we are finding the derivative to which quantity? Y. That is, we don't know. That is unknown function. Other name is dependent variable. The derivative with respect to which variable we are finding? X. So x is called independent, y is called dependent. So one of the variable is dependent, others are all independent. Because this is ODE chapter, one dependent variable and one independent variable. Strictly speaks that if you consider any derivative, the numerator quantity only we are finding derivative. So that's why numerator variable is dependent variable. Automatically the other variable, that is denominator variable, is independent variable. Okay. We are habituated the derivatives dy by dx, d square by dx square, so on, etc. Other representation, y dash, y double dash, prime notation, that is dash notation. Third notation, suffix notation, y1, y2, so on. Fourth notation, f dash x, f double dash x, etc. Fifth notation, one dot. So if any superposition above the variable, a dot is there, that is one time differentiation. Two dots are there, second time differentiation. So that means, why I am telling all these different notations in your question, a differential equation is given in any notation. But we are all habituated the one notation dy by dx, d square by dx square only. But don't think that always that notation and that variables y and x. It may be any two variables. It may be any notation. Okay. Now, first you consider the dependent variable and all its derivatives. They should have power 1. Occur in the first degree only. A dependent variable power 1. Power means degree. Okay. Degree of a dependent variable and all its derivative containing 1 only, and are not multiplied together, but are not multiplied together. What is the meaning of but are not multiplied together? For example, if a dependent variable is y and one of its derivative dy by dx, y into dy by dx, that means dependent variable is multiplying by one of its derivative. That terms, product terms means a dependent variable and its derivatives, or two of its derivatives multiplying. Such terms should not belong to the given equation, otherwise the equation is called non-linear. Okay, products should be absent, then only it is called linear. Products, if any present, then it is called non-linear. What is the meaning of product? A dependent variable multiplying with one of its derivatives, or first derivative multiplying by second derivative, etc. like that. Okay. Example. X dy by dx plus y is equal to x cube. Now here first derivative, y is dependent variable, the power of y is 1, the power of first derivative is 1, these two are not multiplied. Okay, so other terms are x and x cube, they are independent terms. Okay, so is a first order linear equation in which variable? In y, because y is dependent variable. Okay, so while doing problems, solving these problems, I am denoting the short form FOLE. Okay, what is F? First, O stands for order, L stands for linear, E stands for equation. First order linear equation, because highest derivative is first, and the derivative of y only we are finding with respect to x. Okay, so y is dependent, having power 1, and its derivative, one of the derivative is there, having power 1. These two are not multiplied, that's why it is a linear equation. 2. Y dy by dx whole square plus d square y by dx square is equal to sin x. Now here one of the variable, that is y, is dependent, and the dependent variable is multiplying by one of its derivative, and one of the derivative having power more than 1, degree more than 1. Linearity means degree 1. Okay, dependent variable and its derivatives should contain degree 1 and no products with respect to the dependent variable and derivatives. Otherwise the equation is called non-linear. So this is a second order, highest derivative, second order non-linear equation in y. 3. D square x by dt square plus 3 dx by dt plus 2x equal to 0. Now here which is dependent variable? The derivative to which quantity we are finding? X quantity with respect to t. So x is unknown function, also known as dependent variable. So x is dependent variable, t is independent variable. Highest derivative second order, x power 1, first derivative having power 1, second derivative power means degree 1. So no two terms are multiplied here. Dependent variable and its derivatives are not multiplying, they are in separation form. So I can say is a second derivative highest. So second order linear equation in x. So that means any two variables, one of the variable is dependent, other variable is independent. Okay, copy down. Next, initial and boundary value problems. So right now I am discussing all the definitions only, but I didn't start what is the general solution, solution, complete solution, all these procedures for each method. First definition, the condition in bracket S in which the dependent variable, that is unknown function, and its derivatives are specified at ON1, TWO2 or more value in bracket yes values of the independent variable comma is or called initial in bracket boundary condition yes. See, condition or condition, singular or plural, in which the dependent variable I already mentioned and its derivatives I already mentioned and cleared the definition. That means I discussed the dependent variable and its derivatives are specified, that means are calculated at one value or two or more values of independent variable. That means you know how to identify an independent variable as well as dependent variable and its derivatives. Suppose your dy by dx problem, that is y is dependent, x is independent. Solve the differential equation at x values, that is at x is equal to 0, y value some given. At x is equal to 1, some y value is given. So that means your independent variable value is more than 1. X, if I take x values, independent variable 0, 1, that is more than 1 value. Such type of conditions are called boundary conditions. Okay, if I take x is equal to 0, y is equal to 0, x is equal to 0, dy by dx is also 1. Such type of conditions, initial conditions. That means your independent variable value is same in all the conditions. Such conditions are initial conditions. If your independent variable value changes, is different, that conditions are called, the corresponding conditions are called boundary conditions. You know, initial means single, boundary means, you know that meaning of boundary also geometrically. Okay. Now, 2. A differential equation dE together with the initial conditions, comma, is called initial value problem. Similarly, a differential equation together with the boundary conditions, comma, is called boundary value problem. Short form BVP, here short form IVP. So whenever a differential equation with initial conditions, just what I spoke or what I explained, that differential equation is called initial value problem. Similarly, in a given equation, if the conditions are boundary conditions, that differential equation is called boundary value problem. Nothing to explain in that. Just see example. D square x by dt square plus 3 dx by dt, what I considered in the previous definition, comma, x of 0 is equal to 1, x dash 0 is equal to 0 or minus 1. Now here which is dependent variable? X. Independent variable is t. So this is a second order differential equation to x variable with respect to t. Now the conditions here, x, this first condition tells that x value 1, the bracket value indicates independent variable. Which is independent variable? T. So t value 0, x value 1. Here x dash value minus 1, t value 0. So just I am giving an indication. Both bracket terms, that is independent variable value, same, that conditions are called initial conditions and these are boundary conditions. Okay. I mean that conditions are called initial conditions, the problem is initial value problem. Is IVP, initial value problem. Okay. And these conditions are called, in the upper level I am writing initial conditions. CO. Second example. D square y by dx square plus 2 dy by dx plus y is equal to exponential x. Here second order differential equation of y with respect to x I considered. So y is dependent, x is independent, comma, y of 0 is equal to 1, comma, y of 1 is equal to 0. Now observe the bracket values. Here y is dependent, the y value 1 and y value 0. What are x values? X value 0, x value 1. Here x is independent. So your independent variable value changes, that is more than 1. That is 2 values of independent variable x. So this is called boundary value problem. And these conditions are called boundary conditions. The two conditions are called boundary conditions. In the above problem, the two conditions are called initial conditions. Similarly, third order derivative. The number of conditions is with respect to order of the differential equation. If it is a second derivative problem, 2 conditions. If it is a third derivative problem, 3 conditions, like that. Definition: an equation of the form dy by dx is equal to f of x comma y, equation 1, comma, is called a first order and first degree differential equation. Now see, first derivative, highest derivative is 1 and no more derivative, and it is not repeated first derivative. What is the power of degree of this first derivative? 1. That's why first order, first degree. Okay, so all the differential equations of this equation 1 cannot be solved. Only those among them which belongs to or can be reduced to the following methods, going to give following methods standard by the following methods solved by the standing methods. So please remember, all the differential equations of such form cannot be solved in general. Only the problems, those problems which can be reduced or which belongs to the following methods solved by the standard forms. Okay. The methods to solve equation 1 in general are: 1. Variables separable form, short form is VSF. 2. Homogeneous equation. 3. Non-homogeneous equation. 4. Linear equation. 5th one, Bernoulli's equation. 6th one, exact equation. Now see, this method and this method, why I put the 3 ticks? This is so far in my experience, the last, if you observe the last 20-year question papers in all the branches, the variable separable linear equation 95 times, that is 95% times, okay, and this one 5% times, that is 1 or 2 times, okay, and these are 1 mark questions they asked. What is the name of these equations? Okay, so first I am going to start the solving of this differential equation by variable separable method. Solving means we are finding the solution only. Okay, finally solution means which satisfies the given differential equation, whatever you are getting. And you remember the order of the differential equation, that is first order, first derivative there. It's a solution containing only one arbitrary constant, that is called general solution. First of all, what is the meaning of solution? It is a relation between the variables free from derivatives satisfying the given equation, given differential equation, that is called solution. Next, what is general solution or sometimes called complete solution? It is a solution in which the number of arbitrary constants is equal to the order of the differential equation. First order, it's a general solution containing one arbitrary constant denoted by C1, C2, C3 like that. Second derivative problem, it's a general solution containing 2 arbitrary constants. Okay. Next, particular solution is a solution which is obtained from the general solution by giving particular values or numbers to the arbitrary constants. Okay. Just what I spoke, what I explained, these definitions you can easily understand if you refer any normal textbook containing differential equations or your material also. Okay. First method, variables separable form, short form VSF. A differential equation is said to be in variable separable form, comma, when dx and all terms containing x are at one place and dy, comma, all terms containing y are at another place. That is, the equations of the form f of x into dx plus g of y into dy is equal to 0, or other representations I am keeping in brackets for understanding purpose or avoiding confusion. F of x dx is equal to g of y dy, or dy by dx is equal to f of y divided by g of x, etc. Comma is called VSF, and this first form say equation 1. Integrating 1, comma, we get integral f of x dx plus integral g of y dy is equal to c is the general solution, short form GS, of the given differential equation. What is C? Arbitrary constant or constant of integration. So the first order differential equation, first rearrange the terms of the equation and bring into the form dx, all terms containing x are at one place, dy all terms containing y are at another place, just like fx x terms dx one place, dy y terms are at second place. Here left side x and dx, right side y terms dy are like this. Any of these form is called variable separable. Once you bring the given equation into such form, that is called VSF. To get the solution, what we have to do? Integrating both sides we get. That is one time integration, we are getting one arbitrary constant. Don't say that one time integration, the procedure, the solution is obtained by integrating only. I already told you the general, we are seeking that general solution. Our intention is finding general solution. Even though the question asks find the solution, it means that general solution only. So how many arbitrary constants? Because of first derivative problem, it contains first derivative problem, first order equation, one arbitrary constant. Suppose if a problem is difficult to bring like this, any one of this, that is called non-variable separable. Okay, it is not variable separable form. Okay, in such case, one substitution procedure is there. Okay, let me solve one example on this, and I consider one more example which is not expressing into this form. Then how to do that problem? 1. Which is given 2007, 2 marks. The solution of dy by dx is equal to x square, is equal to y square with y of 0 is equal to 1 bounded in the interval. Options: A, minus infinity less than x less than infinity. B, minus infinity less than x less than or equal to 1. C, x less than 1 comma x greater than 1. D, minus 2 less than or equal to x less than or equal to 2. Now here solution means the dependent variable, unknown function, that is y. We are going to find y is equal to in terms of x, that is with using the conditions, initial conditions, boundary conditions explained. What is the purpose? To determine the arbitrary constant values, to give the arbitrary constant into a fixed value. Okay, so that means y is bounded in the interval. Suppose if you get while solving y is equal to 1 by x, 1 upon x, that is defined everywhere, bounded everywhere except 0. 1 by 0 is not defined. So in such way, that means one example I considered. After solving, you see that solution, find y is equal to in terms of x, and according to the options, you find the corresponding x values, that is domain. Okay, y is defined everywhere, that values of x are called domain. Now, dy by dx is equal to how much? Y square. So separating the variables means, first of all, keep dx dy terms into the numerator and x terms into dx place, y terms into dy place. That is our second step. After that, third step is integrating. So dy is already in numerator, dx is denominator. Bring all dy, dx, dz, dt, any terms into the numerator and then respect to variables. So dy by y square is equal to dx, I can write. So this is variable separable form, VSF. After that, integrating. Okay, so this gives minus 1 by y, integral dx is x plus c. Since integral 1 by y square dy is nothing but integral y power minus 2 dy is equal to y power minus 1 by minus 1. That is, I used the formula, basic standard first formula integration, that is x raised to n, x power n integration. Okay. Now let us say this is equation 1. Take the given condition. Okay. Given y of 0 is equal to 1. What is the meaning of this condition? that is y value 1, x value 0. Y is equal to 1, comma x value 0. Substitute these values in 1. That means 1 gives minus 1 is equal to y value 1, minus 1 upon 1, minus 1, c plus 0, c. So this is the value of c obtained from this condition. Again go back to your solution, substitute this c value, or I can say this is the general solution, short form GS. So therefore 1 becomes minus 1 by y is equal to x minus 1. From this I can write y is equal to 1 by 1 minus x. So this is your solution. SOL stands for solution. Finally I expressed the dependent variable unknown function in the beginning stage. Now it is going to become solution because we solved, we got the answer. Now this function is defined everywhere except 1 only. At x is equal to 1 it is undefined. Okay. Therefore y is equal to 1 by 1 minus x is not defined at x is equal to 1. Implies solution y is equal to 1 by 1 minus x is unbounded if x not equal to 1. Sorry, if x is bounded except 1, it is going to define everywhere. It is giving finite value. Bounded means finite. If x is equal to 1, it is not defined. That is unbounded. So it is bounded if x not equal to 1. That is not equal to 1 can be written as less than 1, greater than 1. What is the meaning of not equal to 1? Other than 1 value. That means all other than values 1 can be written as less than 1, greater than 1 only. On the real number except 1. What all other numbers can compare it as two types, less than 1 and greater than 1. That is the meaning. Bounded means finite, right? By the, I explained in calculus part, bounded, unbounded, all these things, words. So according to the options, C is the right answer, put the tick. This is given 1995. If at every point of a certain curve, comma, the slope of the tangent equals minus 2x by y, comma, the curve is A, straight line, B, circle, C, an ellipse, D, a parabola, straight line, a circle. So what exactly tells that general solution? It represents a family of curves. We know the standard curves, circle, ellipse, hyperbola, rectangular hyperbola, parabola, straight line, all this 2D geometry. Okay, there are so many curves, we don't know the name. Okay, every solution represents geometrically a family of curves only. So what is dy by dx? Slope of the tangent. Okay, so given dy by dx is equal to minus 2x by y. So this is slope of the tangent. Easy to separate the variables. Dy is the numerator. Bring all y terms to left side. Dx is in the denominator. Send into right side. Keep x terms into the right side. So dy, that is y times dy is equal to minus 2x times dx is variable separable form. Implies integrating. INT stands for integrating. Y integration y square by 2 minus 2 into x integration x square by 2, 2 cancel, plus c. So therefore what tells x square by 1 plus y square by 2 is equal to c is an ellipse. What is ellipse standard equation? X square by a square plus y square by b square is equal to 1. Straight line equation, y is equal to mx passing through origin, y is equal to mx plus c does not passing through origin, and x by a plus y by b is equal to 1. It is a straight line in intercept form. So many straight line standard forms. And circle equation, x square plus y square is equal to a square, center 0 0, radius a. X square plus y square plus 2gx plus 2fy plus c is equal to 0. That is also circle equation in standard form. Hyperbola, x square by a square minus y square by b square is equal to 1. And x square minus y square is equal to a square, rectangular hyperbola. X into y is equal to a square, that is also rectangular hyperbola. Just refer 2D textbooks what we have studied in coordinate geometry in +1, +2 level, 11th standard, 12th standard. Okay.